All right, so let's go ahead and finish up Unit 1 with Section 3, which is going to deal with graphs and scientific notation, and also talking about the importance of organizing and presenting data. So a couple of the key ideas that we need to go over are why is organizing data an important science skill? How do scientists handle very large and very small numbers? And how can you tell the precision of a measurement? So with presenting data, most people use either data table or most scientists either use data tables or graphs. So let's talk about a few of the main types of graphs that can be used, with presenting data. The first one is line graph, is used to show continuous change over time. So the bar graphs in comparison is used to compare similar values for a collection of items. Then the last one is a pie graph, or also called a pie chart. It is used to display data as parts of a whole. So for instance, if you were collecting data over a lot of days or weeks or months or years, and you want to compare the change over time, then you need to use a line graph. If you have different control groups or experimental groups that you're wanting to compare data from, then you might want to use a bar graph to look at that relationship between the groups. If you're looking at parts of a whole, if you're looking at your entire work in one 100% look, then you might use a pie chart to present that data. All right, so scientific notation is what scientists use to reduce the number of zeros in very big or very small numbers. And the data can be expressed as simple numbers multiplied by the power of 10. So again, this is going to go back to finding the decimal, right, and either moving your decimal left or right. You move the decimal left to get rid of zeros, it's going to be a positive exponent. If you move the decimal right to get rid of zeros, then it's going to be a negative exponent. So, large number rule. So you count the number of decimal places you have to move the decimal to the left to get your exponent, all right? So if we are looking here, the decimal, imaginary decimal is right behind the zero. 1, 2, 3, 4, okay? All right, so we moved our decimal 4 places to the left. So I moved it to the left, so it's a positive exponent. 10 raised to the fourth is 10,000, right? We look at 30,000. Here's my decimal. 1, 2, 3, 4. Okay, 3 times 10 to the fourth is 30,000. All right, so now let's look at 570,000. Here's my decimal. 1, 2, 3, 4, 5. I'm going to stop in between the 5 and the 7 because those are significant figures. Okay, so it's 5.7 times 10 to the fifth. All right. So let's look at some practice down here. All right, I am going to leave this, and then in another video I will go over these, okay? I will make another video where we go over the practices. All right, so in comparison will be the small number. You use negative exponents for numbers less than 1. To determine the exponent, count the number of the decimal places you must move to the right in order to leave only one digit to the left of the decimal place, okay? So here's our decimal. 1, 2, 3. One digit to the left, there's 1. Okay, so it's 1. 10 to the negative third is 0.001. So if we look here, 1, 2, 3, 4, 5. Decimal ends up between 5 and 7. One digit to the left of the decimal. 5.7 times 10 to the negative 5. Okay, all right. So we can go on down this line here, and we'll end up with the decimal here, times 10 to the negative whatever space that is, and then on down to the next one, okay? All right, a couple of vocab terms. Difference in accuracy versus precision, okay? Precision is the exactness of a measurement. Accuracy is how close a measurement is to the true value of a quantity, right? So precision, exactness of a measurement. Accuracy is how close a measurement is to the true value of a quantity. All right, and that is the end of chapter 1. So be sure you complete the, or unit 1. Be sure you complete the video form that goes with this lecture, and be looking for next week. You'll get a study guide or a review guide to help you begin preparing for your unit 1 test. If you have questions, be sure to let me know. Thank you.